Assalamu alaikum, my dear students. Hoping that you are all fine with the blessings of Almighty Allah. And we are supposed to start now our lesson. And let's now start without any delay. Already a lot of time I have to send every time lesson to most of you, the people, most of the students to join me. I don't know why not joining by yourself. Next time, no. On Saturday 5:35 the lesson will be started. I will not send message even a single person. I mean, you are not responsible. After the lesson, I will send the message to your parents that they did not join or they joined at this time. Enough is enough. And more than 50%, almost 50% people submitted the quiz. Rest, just taking rest. Let's see, inshallah. Let me correct it, then your parents will be contacted. Not this way. Exams are approaching and you are just in the mode of not doing work on time and not taking the thing serious. This will not work. Physics of waves. This is block 3 of the syllabus. Block 3. And according to new pattern, it is 18%. Third comprehensive block of the IGCSE physics. So 18% of the syllabus is physics of waves. Even you can say comprehensive role it will have in the exams. So in exam it has comprehensive portion in paper 2, paper 4 as well as paper 6 also. It is there. Now few things just as an information before I start. First of all, wave. When we talk about wave, it can be electromagnetic, it can be electromagnetic wave, it can be mechanical wave. Mechanical wave is medium dependent. Mechanical wave medium dependent. In other words, it needs a medium. No medium needed. Here medium, oh my goodness, I wrote it wrongly. No medium needed here, and here medium needed. I will explain it. Electromagnetic waves, they are only transverse. They are only transverse. Mechanical waves, they may be transverse or longitudinal, depending. Longitudinal. Now first of all, maybe you are thinking, sir, what you are talking about medium. When we say medium, medium means solid, liquid or gas is there where these waves are generated. When we talk about mechanical waves, right now you are hearing me, sound waves are there, they are mechanical waves. They are a best example from IGCSE point of view of longitudinal waves. But sound cannot travel in vacuum. Sound can travel only in air, in water, in solids. Mean in air, in liquids, in solids. Without the presence of this medium or these states of matter, sound cannot be generated, sound cannot be traveled or transmitted from one place to the other place. Water waves, mechanical waves. Water waves, mechanical waves. Also water is a type of medium, liquid. So transverse waves, water waves are basically an example of transverse waves. And so on and so on. Now another important thing, these mechanical waves, they are produced by disturbance in a medium. They are produced by disturbance in a medium. How? Right now I am of course creating a disturbance in the air molecules. A tub of water is in front of you, and a piece of soap or the cup containing water itself, or let me say a piece of stone is dropped into the water. What happened? There is a disturbance into the medium. Water is disturbed, and as a result the ripples of water will be moving this way. So whenever we talk about mechanical waves, they are the medium dependent and they are produced by the disturbance into the medium. So this is first of all talking about mechanical waves. Mechanical waves. I will start with this electromagnetic waves. There is a complete chapter on this, the last chapter on electromagnetic waves. So we will discuss them in detail over there. But right now mechanical waves, they are medium dependent. They need a medium to travel from one place to the other place. They may be transverse, they may be longitudinal, and also they may be transverse, they may be longitudinal, and they need a medium for them to travel from one place to an other place. One place to an other place. Let's start with now transverse waves. Mohammed, you joined me now when it is 48 minutes past 5. Mean 18 minutes are gone from the scheduled time of class. Next time after 5:35 I will not let you enter. Not only you but anybody. First your parents will contact me, then otherwise leave. No need. Look for another teacher. What does this mean? Joke you people have started. Whenever you wish you are entering. Weeks you are not part of the lesson, all of a sudden you are entering into the lessons. No my dear friends, this will not work. There is a connection of each topic with the next one. When connection is broken, nothing you can understand. And remember it now. I am talking about your brother Muhammad. He joined just now. So anyhow, transverse waves are the waves in which oscillations, even you can say vibrations, are at right angles to the direction of travel of wave. For example, water waves, electromagnetic waves, they are all examples of transverse waves. And by the way, what are electromagnetic waves? Just let me say right now their names. Electromagnetic waves are consisting of radio waves, microwaves, then infrared, visible light, ultraviolet, X-rays and gamma rays. There are 7 parts of electromagnetic waves and all of them are transverse. So in transverse waves, the vibrations are oscillations. In other words, you can also say the disturbance are all at right angles, which means are at 90 degree to the direction of travel of wave. Water waves are like this. Okay, so nowadays it's not necessary that they will write to the direction of travel of wave. Also they are writing direction of travel of wave or direction of energy transfer, because waves, they are carrying energy, they transfer energy. So it can also be in the direction of energy transfer. Please remember it. You may find this term into the mark scheme, so it's okay. Now one thing very important, remember always, any type of wave, either it is mechanical or it is electromagnetic, it is transverse or it is longitudinal, all of them are transferring energy from one place to the other place without transferring the matter. Without transferring the matter, energy is transferred without transferring the matter. Like many examples we can take, and as we will proceed forward, so we will discuss them. So right now, transverse waves are the waves in which oscillations, vibrations or disturbances are at right angle, mean 90 degree to the direction of travel of the wave. For example, water wave. Here in this diagram now, I'm giving you an example here, that let's suppose this is the direction of the wave. I'm just assuming like this. This is the direction of wave. This way. This one we can call it rest or undisturbed position. Rest or undisturbed position, this horizontal line. Now these are the particles, this red line, the red, this curve wave, that is the particles vibrating, particles oscillating like this. So if I'm talking about this particle, its vibration and direction of motion, what is the angle here? 90 degree. If I'm talking about this particle here, so angle is what? 90 degree. Any point you choose over here on this wave, that will be vibrating, oscillating at 90 degree to the direction of motion of the wave or to the direction of energy transfer. So that's why we are calling them transverse waves. We are calling them what? Transverse waves. Okay, now next, my dear friends, longitudinal waves, we will study them in detail in the next part. So I will just say you the definition, but I will try to complete very important definitions after this. Now longitudinal waves are the waves. Longitudinal waves are also known as compressional waves. This is more important. They are also known as compressional waves. Are the waves in which oscillations are in the direction of travel of wave or in the direction of transfer of energy. In other words, theta is equal to 0 degree. Up there, angle was equal to 90 degree between the vibrating particles and the direction of travel of wave. Here oscillations are also in the same direction as the direction of the travel of the wave. So we will call these waves compressional or longitudinal waves. And the best example for them, are the sound waves, or we can say P waves. But I will explain you this thing in the topic next page, after these basic definitions. Now let's start. First of all, I did not write it there. Crest. The highest point on a wave is crest, and the lowest point on a wave, this is what? This is the trough. So crest and trough, in this way we can define. Now the first very important definition is amplitude. Amplitude, it is the maximum displacement of a wave from rest or undisturbed position on either side of the wave. Unit is meter. System international unit is what? That is meter. Just give me a few seconds. Okay, my dear friends, now next is no, not next, still I need to explain it. Wait a minute. Okay, so it is the maximum displacement. Displacement is the shortest distance between 2 points. Maximum displacement of a wave from rest to or undisturbed position on either side of the wave. See, if I'm talking about this one, see, this is the rest position and this is the from rest to the extreme position, amplitude. This is the rest position on trough and this is the extreme position. So from here, rest to extreme position, the distance is amplitude, or from rest to extreme position in the peak. You know, crusts are also known as peaks. So this is amplitude, this length is also amplitude. So again, it is the maximum displacement of a wave from rest or undisturbed position on either side of the wave. Let me say it once more, that from here till here, this distance is amplitude. I can denote it with capital A. From this peak to the rest position, this distance is also amplitude. So it is, in other words, for understanding, you can say height of a peak or height of a trough. Like this you can say. But technically, if it is asked in exam, mostly it is part of the MCQs, and I will discuss with you many, and you will be getting the homework, of course. And now next, today is Wednesday, you have one complete week. Next Thursday evening, not tomorrow, there is a complete block thermal physics quiz. Remember it, and I will be sharing with you on the group also on WhatsApp. Anyhow, so the distance from the undisturbed position or rest position to the peak, or distance from the rest position or undisturbed position to the lower peak, you can say, or to the trough, that is what? That is amplitude. In many ways you can say it, but the system international unit is what? System international unit is meter. Anybody having any question, query, doubt or regarding this, feel free and ask me. Next. Anybody having any question, please feel free. You people can ask me now. Okay, wavelength. See its symbol. You can say almost inverted Y. Almost inverted Y. It is read as lambda. It is read as lambda. Now, it is the distance between two neighboring crusts or troughs. It is the distance between two neighboring crusts or troughs. Or I can say it is the distance from one crust to the next crust. Let's see it here. Now you can check from here till here. This is wavelength. Similarly, from this point to this point, this is also wavelength, which is denoted by term lambda. So the distance or the length between two neighboring crusts or neighboring troughs or you can say distance from one crust to the next, very important, or we can say it is the distance from one crust to the next crust. It is the distance from one crust to the next crust. Why I am writing it in this way? There is a reason. Like very common question. It is a very common question in paper 4, even in paper 2, sorry. Like, no attentive, and you will answer me. I am not going to answer first. Muhannad, Awad, Sharafuddin, Muhammad Hisham, Mahdi Umar. Get ready, all of you, from Ghana, right now. I am going to ask you this question and you have to answer me this question. Simple is that. This is a wave. And remember, let it be x in centimeters. This is y in centimeter. The distance from this crust to this crust, it is 20 centimeters. Distance from one crust to the next crust, this is 20, now this is 20 centimeter, mean this distance as it is shown on the graph, on the diagram, 20 centimeter. Now my question from all of you, what is the wavelength here? Everybody write in the chat box. You have hardly 1 minute. What is the wavelength of this wave? Mahdi, perfect. Alhamdulillah. Veda, okay. Alvira, okay. Ali Muhammad, okay. Ruba, okay. But where are the others? Muhammad Hisham, are you sleeping? Awad, Muhannad, my dear friend Sharafuddin. Everybody. Mahad Rafi, correct. Sharafuddin, mashallah, very right, my dear friend, correct. Muhammad Hisham, Awad, Muhannad, where you are? Okay, now let's see. What is the answer? Okay, now what is the answer? Majority of the students have said it correctly. Answer is 10 centimeters. Why 10 centimeters? Wavelength is the distance between two neighboring crusts or troughs, or it is the distance from one crust to the next crust. From here till here, this is wavelength lambda. Then from here till here, again this is wavelength lambda. So what can I say? Lambda plus lambda is equal to how much? 20 centimeters. Because it is the length from one crust to the next crust. From one crust to the next crust. So 20, it is lambda plus lambda equal to 20. So we can say that 2 lambda is equal to 20 centimeters. And this implies that 20 over 2, it will be equal to 10 centimeter. No need to sleep in exams. Even We teachers sometime in hurry worry telling that it is the distance between two crusts. It is the distance between two troughs. That is the nonsense to say the teacher should take rest when he is saying this thing. It is not from crust to crust or trough to trough. It is from one crust to the next, or it is from one trough to the next, or between two neighboring crust, or between two neighboring troughs. Here what happened in this diagram? Yes, it was from crust to crust, but not from one to the next. So what we did, we started marking the wavelength which is from one crust to the next, lambda, then from here till here again lambda. So lambda plus lambda equal to 20 centimeters. It means 2 lambda is equal to 20 centimeters, and on simplification lambda will be equal to 10 centimeters. Anybody having a doubt? Any problem? Quickly. Now another definition of wavelength which is very common nowadays in paper 4 as well as in paper 2. This one, whatever we did till now, this is the old definition for wavelength. It is not wrong, but in old exams, but now they are always having a research team which is working all the time. Wavelength. See, this wavelength is the combination of two words. So that's why I wrote it is the length of one complete wave. It is the length of one complete wave. Wavelength. It is the length of one complete wave. Wavelength. What is one complete wave? It means it is consisting of one crust and one trough. So one crust and one trough, they are making together one wave. How to draw it? Now this length which is shown in front of you right now, this is equal to wavelength also. Why? Because it is consisting of one complete wave. It is consisting of one complete wave. Because there is one crust, there is one trough. So this is also equal to wavelength, and this is a new style in the exams to ask about the wavelength. It cannot only be like first trough and then crust. It can also be in the reverse order. I will draw here in a shortcut. It can also be like this. This is also a one complete wave. Because there is one trough, there is one crust. So this length is also equal to wavelength. This length is also equal to wavelength, lambda. Now the system international unit for wavelength is also what? Meters. Next, frequency. It is the number of waves passing through a point in 1 second, or even you can say number of waves. Frequency, I can write number of waves, even number of wavelengths per unit time. That's what I have written theoretically at the top. Number of waves passing through a point in 1 second, that is the frequency. It is having the unit of hertz, and Hz capital, H capital, Z small, or waves per second is the unit of frequency. And remember, frequency is not denoted by capital letter F. It is denoted by small letter f. So it is the number of waves passing through a point per unit time, or number of waves per unit time equal to frequency. How we can understand it? For understanding, come here. Roughly I have drawn these diagrams. Now if this wave is completed in 1 second and all these waves are also completed in 1 second, then my dear friends, how many waves are completed here in 1 second? The number of waves completed here in 1 second, there is only one wave, so frequency of this upper wave is 1 hertz, because only one wave is completed in 1 second, whereas in this case one crust and trough, one wave crust and trough, second wave crust and trough, third wave crust and trough, fourth wave, here 4 waves are completed in 1 second, so frequency is 4 hertz. How much is the frequency? Frequency is 4 hertz. Frequency is 4 hertz. So where the waves are packed together, closer together, instead of saying waves, we can say where crusts and troughs are packed together, closer, frequency is high. Where they are further apart, frequency is lower. So frequency is the number of waves passing through a point in 1 second. It has the unit of hertz or waves per second. Next is now period or time period. We have studied it already in chapter number 1, period of a pendulum. Here also the same. It is the time taken for a wave to produce one complete wavelength. It has SI unit of second. Diagram is already there. See, this is one complete cycle. So whatever the time will be taken here, that will be equal to period. So time required to complete one wave, that is period, or time in which one wavelength is completed, that is also the period. It is denoted by capital letter T and unit is of course second, but important thing is period and frequency are reciprocal to each other, mean if the frequency is more, period will be less. It is not necessary that period is 1 over frequency. We can also write frequency is equal to 1 over period. So they are reciprocal to each other. Nothing new, nothing special. Now speed, denoted by letter V. It is the distance traveled by a wave per unit time. It is the distance traveled by a wave per unit time. It has the SI unit of meters per second. SI unit of meters per second. All the boys, I'm sure you are listening me, turn on your mobile, turn on your cameras. I want to see you are in my lesson or you are sleeping. All the boys are told to turn on their cameras of their gadgets. Hurry up. Okay, my dear friends, so that I can see what you are doing actually. So speed, it is the distance traveled by a wave per unit time. It has the unit of meters per second. Very simple definition of speed. But my dear friends, Ahmad Abdu is there, Ali Muhammad is there. Ahmad Abdu, why did you stop your camera? Girls no need, but only boys right now. Okay, so let's move forward. Another so much important thing, speed of a wave. In waves, not only we will be using speed is equal to distance over time, but also we will be using speed is equal to frequency times wavelength. Frequency times wavelength. So speed of the wave is equal to frequency of the waves times the wavelength of the wave. Times the wavelength of the wave. So V is equal to F times lambda. F is for frequency, lambda is for wavelength, and V is for speed. And this formula, my dear friends, in externals it will be from 1 mark to 4 marks question. It will be used in questions from 1 mark to the 4 mark, till 4 marks, very important. Next is, this formula should be in front of your chair, on the table, in front, or on the wall, wherever you are studying, on beside your study table, on the wall with a sticky note, flashcard, it should be there, along with the other formulas. Frequency and wavelength of a wave are related to each other by, frequency of a wave is inversely proportional to wavelength when the speed is constant. Now come here, this is important. I can tell you this thing. See, V is equal to F lambda, and this equation will help us out. If you ask me what is the wavelength here, the wavelength is the length of one complete wave. See, here is the wavelength. If you ask me what is the wavelength here, length of one wave, so wavelength in this one is this one. Now we can observe that in this diagram, upper diagram, wavelength is more. If we put the ruler, mumkin it is 5 centimeter from here till here. But if we put the ruler here, mumkin it is 1.5 centimeters. From where? From here till here. Now here, in the upper diagram, wavelength is more. In the lower diagram, wavelength is less. In upper diagram, wavelength is more. In the lower diagram, wavelength is less. But observe now. See, they traveled same distance from here till here. From here till here. Time is also same. It means speed is constant. But when wavelength is more, frequency is less. And when wavelength is less, frequency is what? More. So that's why, my dear friends, I have written here that frequency of a wave is inversely proportional to the wavelength. Or you can say wavelength of a wave is inversely proportional to the frequency. They are inversely proportional to each other, but the speed is kept constant. And many questions you will find on this in exams, especially when we will be talking about the electromagnetic waves. Okay, now the last thing before these definitions, and we will move to the, now here I have switched the topic, Shoya. I started first with chapter 14 basic definitions. Now I will go to sound waves after this in the next section of the lesson today. Wavefront is the imaginary line that join all the points which are in phase. In general, crest of a wave is taken as wavefront. Now you people, listen, you people need to know only that crest of a wave is the wavefront. I still remember in 2014, in a workshop with the principal examiner, I met that person 2 times. After that also I met him. So it was, he was asked about, sir, how to explain Mahad, how to explain Mahdi, Sharfuddin, Muhammad Awad, Muhammad Hisham, and all my students right now in lesson, how to explain them, how to tell them what is a wavefront. Because the definition itself is complicated. You must know what is a phase and all these things. So his answer was very simple. That tell you actually the crest of a wave or the top of a wave, they are the wavefronts. But tell your students, whenever they are finding a term in exams, wavefront, they should consider the wavefront as a crest of the wave. And like many times you will find in paper 2 and paper 4, my dear friends, vertical lines like this, this, and they are saying these lines are wavefronts. They are what? Wavefronts. And they may ask you, label the wavelength. And according to the examiner, principal examiner, wavefronts are the crests of the wave. They are what? They are the crests of the wave. So, from one crest to the next crest, this length, it will be known as wavelength. Even this length will be known as wavelength. So, they will be helpful to us in finding the wavelengths in different situations. I'm sure you got my point. Now, if any one of you is having any question regarding this all, please feel free. People can ask me. Now, you all can switch off your cameras. It's okay, no problem. Now you can switch off. Anytime I can tell you to turn on the camera again. Right now you can switch off your cameras. Okay, my dear friends, now if you have any question here, please feel free. You people can ask me. Then in 2 to 3 minutes, I will be restarting the recording. We will be starting the lesson, and we will be discussing few things about sound waves, and then in the end of the session, we will be solving some past paper questions. Stay blessed of all of you, and you have a break of 4 minutes now. At 6:28, we are going to start again. 6:28, we are going to restart our lesson. Stay blessed.